then you want to draw this vector going this direction, length 70, angle 45 degrees. So we have two ropes that are pulling, okay, in different directions. What is the resultant force on the point? Okay, all this is vectors that you guys have already done, okay? So we're going to look at our two ropes. And these are even easier in some ways because they already found the reference angle. Quadrant 1's pretty easy. Over here we have quadrant 2. They already gave you the reference angle, okay? So for this vector, for our cosine, we have a push to the right. So that's going to be positive cosine, right? And our length always goes in front. So we've got 40 cosine of 30 degrees. Okay, then we have a pull in this direction, which is negative because it's going to the left, right? And then same thing, our length goes first and our angle inside the trig function. So this would be minus 70 cosine 45. And all of this represents I hat for our vector. Okay, plus, now we've got our sine, which is our j hat, both going up. Okay, just what you guys have been doing. So for this one, length first, angle inside, and it's positive. So 40 sine 30. And my other one is also positive. So this would be 70 sine 45. And this is a j hat. Okay. Somebody go ahead and tell me the decimals for this and for this. Anybody got a cosine decimal for me? Good. All right, so we calculate those. Now, I want you guys to look at this picture. When you guys are doing force vectors, I just want to show you where it ends up. What you want to do is make a parallelogram. So I can draw a dotted line so that I'm like parallel with the line over there, and another dotted line that's parallel here. And what that does is it gives me my resultant vector, this guy right here. So the one that we just found represents that vector. So what would happen if I pulled this direction and pulled that direction? That's where I would end up, right? A little more to the left. We've got a little more pull on the one to the left, right? Okay, so now we convert it back to polar on these. So we've got Pythagorean theorem, again, 14 point. Okay, we do not need any negatives. All right, and then our inverse tangent of 497 over 14.856, no negatives. Okay, anybody got Pythagorean theorem for me? Angelo, why don't you do Pythagorean theorem? Karis, can you do inverse tangent for me? All right, cool. So 77.934, you guys, what quadrant is this vector in? Whoa. It's in quadrant 2, right? It's negative positive over here. So that means I found the angle inside. So I have to do 180 minus this answer, and that would give me 102.066 degrees. Whoa, a little crazy today. All right, so always convert back to polar. So then we know exactly where our answer vector is. The length of the vector would be 71, and the angle where it ended up. Okay. All right, go ahead and draw this picture. And make note, this vector, the arrowhead is actually pointing in, which is important. And then this one is like our normal vector is pointing out. All right, so we've got our 16 length and our angle of 30. So think again about our cosine going this way and our sine going this way. So my first vector, Clint, would be what for cosine? Okay, 16 cosine 30. Good. Now, the second vector is something we haven't done before because it's flat. All of ours have actually had an angle off of the x or y axis. This one is exactly on the x-axis, right? And it's pointing towards 0. So the first thing you want to do in your head is pick it up and move it. So what I'm going to do is I'm going to place this 10 right here because it's facing inward. If it was facing outward, you would leave it where it was. But because it's facing towards 0, we're going to move it to the other side. Still a length of 10. So what this does is it's adding 10 only to the x-axis. Do we have any up or down movement on that vector? No, there's no force going up, no force going down, which means we're just adding 10, and that's it. No angle because it's just flat. Okay, so it's just a plain 10 on the x-axis, so it's added to the I. All right, now let's do our sign. So Zach, what would I write for this upward force from this vector? Good, except for it'd be sine because it's going up, right? That is right. So 16 sine 30. And now this red vector right here that has a length of 10, you guys, it's not moving up or down, right? So what do you think we should put? Good, plus 0. We're not adding anything to the y-axis on that one, so we put plus 0. And then you guys can figure out the rest. 3 decimals, back to polar, right? I want to show you one thing before we do whiteboards, all right? This is really important, so you might want to write this down. Okay, here's my xy axis. Let's say I have a vector that goes up like this and is a length of 5. If it's going up, is that affecting sine or cosine? Sine, good, which is the j. So this would be plus 5j, right? And it would be a 0 for the I if you're going straight up. All right, let's say we're going straight down. And it's also a length of 5. What do you guys think, Emma, for the j? Very good. It would be a minus 5j, and it would still be a 0I because both the upward force and the downward force have no direction left or right, okay? All right, so same thing now if I go the x. So let's say I go this way, and this is a distance of 5. Okay, so for the I, Bree, what do you think it would be? Exactly, negative 5I and a 0j because we're not going up or down. Okay, and then the last one, if it was going this way and it was a length of 5, it would be plus 5I and 0 for the j. Okay, and the last thing again, if you have a vector that points inward, so like say I have this, I'm trying to like so you can actually see it. If it's straight down towards 0, you're going to pick it up and move it because it's the same force if we pick it up and move it. So this really means this. So this would be a minus whatever the length is, okay? So think of it as down here. All right, let's try one problem on the whiteboards.